Sir, I'll just introduce, I think we'll get started. Thank you everybody for joining us. Today we are here to review the project presentation by our interns at MRC. We have 5 presentations today. A few of our students got affected by COVID, so some of them are not able to present now. We may have to look at that separately. Today we have 5 presentations and we have a very esteemed panel today. General Patil sir is here, who is a maritime, a security strategist, has many years of experience, has been at the highest level in the army, and he's been very kind to us at MRC, guiding us on various issues related to maritime to the national security. Commodore Rajan Veer sir is here. I would say somebody who joined the Navy before independence, and more than 50 years of maritime capabilities, and he is got the distinction of starting the first maritime foundation in India in the private sector, and he has been tirelessly taking it forward, and I been a mentor for me when I started this. We have Ashwin Shroff sir, who's the chairman of the Excel Enterprises company, which has been there for many decades and really done remarkably in terms of the industrialization in the country. Professor Ajay Dandekar sir is here, professor at the Shivnada University, a historian, but somebody who understands strategy in a very, very different sense. So today, the projects that we have, as we all know, that our focus has been on the underwater domain awareness framework, and we have tried to cover multiple aspects of the UDA framework, right from policy to technology, and you will see some variety today. This is also a result of the work done by many interns before this also, and with every of our project, they go to a different level of maturity, and we are happy to have some very bright young people today. I will request Sridhar, uh, my colleague at MRC, who has been spearheading the backend efforts at MRC, to quickly give a small brief, or maybe Sridhar, 2 minutes, on how we conduct these internships and how we conduct these research. Sridhar, over to you, please.
Thank you, sir. Good afternoon, everyone. My name is Sridhar Prabharaman. So internships we have in MRC, we divide the deliverables that are provided by the interns. We assign them projects. We give them a list of projects from which they can choose one that they like, and after that, at the end of so currently this batch of students we have an 8 weeks internship. So at the end of 3 weeks, they are requested to provide provide a research note. A research note is basically a thorough literature survey of the work that has happened before us, I mean, before their project in that particular field. Whatever work has happened throughout the globe, India and across, and what is the current establishing what is the current state of the art. And within the research note, they also outline what is the need, what are the gaps. They identify what the gaps are, and they identify what are the applications, what are the recommendations that they have could be as a future scope of work given in that particular project. Followed by that, we request them to provide a flowchart, which is basically a complete design of how their final submission is going to be. The final submission being either a policy paper or a tool or a framework or anything, depending upon the project that they choose. It is supposed to outline everything, starting from what data to use, what kind of tool to use, what is the method that they're going to use, what are the mathematical models they are going to establish, and so on and so forth, and combining all of them together, how they project their project is going to come up as. Um, Followed by that, then we have regular meetings every week where we kind of go through their work. We see how much progress they've made, and in terms of project work, as well as in terms of their overall uh, development of the tool per se. And Yeah, and after that we take up presentations, and this is one of the final presentations where they'll be presenting upon the topic the work that they have done so far, and more importantly, outlining a bit towards what are the applications of their work, going elaborately over where do they feel their work presents in the current UDA framework. That is it. Should I request Tanvi to start with the presentation, please?
Yes, sir. I'll just share. Is my screen visible? Is my screen visible? Can
Please go
everyone
ahead.
see?
Yes.
Yes,
Yes.
it is visible.
Good evening, everyone. My name is Tanvi Asolkar. I'm a final year student at Monash University, Malaysia, pursuing the Bachelor of Business and Commerce. So today I'm going to be presenting on my research project at MRC, which is the Bluebond Initiative for the Underwater Domain Awareness Framework. So here is an outline of all the topics I will be covering in this presentation, starting with an overview of the initiative, followed by its objective, the link between the blue economy and sustainability, and its relevance for the UDA framework, applications for India, followed by limitations and scope for the future. So to begin, blue bonds are a financial instrument solely meant for financing ocean-related projects. It is a debt instrument under which governments, financial institutions, and development banks raise capital from impact investors to finance marine and ocean-based projects that have positive environmental, economic, and climate benefits. Such types of bonds give confidence for capital markets and global institutions to take stewardship of promoting and helping countries develop their blue economy by raising the funds required to transition towards one. It is aimed at enabling India to develop its blue economy by highlighting sustainable mechanisms available to it, such as blue bonds. As a relatively new concept, blue bonds lack ICMA certified principles to govern it. However, they can be issued as a subset of green bond principles, adapting them to suit blue projects. The concept of the blue economy emphasizes conservation and sustainable management of oceans, signaling ocean stewardship. The UDA framework is aimed at providing effective governance of oceans, enabling sustainable use of undersea resources. Given the diversity of ocean economic sectors and their impacts on the ocean, it means that there are many different dimensions of ocean sustainability. To help focus policymaking in ways that can shift the balance towards sustainable practices, it is useful to reframe the ocean economy according to their relative dependence on the ocean ecosystems. For instance, sectors that are economically dependent on ocean natural capital, such as fisheries, require policies that capture the future value of that natural capital combined with clear regulation and enforcement. Whereas sectors that are physically located in the ocean but not dependent on natural capital, such as energy and shipping, require different policies that are focused more on accounting for ocean environment impacts and damages. These sources of financing can be categorized into two major components. Firstly, support for governance reform, ecosystem based management of marine areas, and other resources required to transition towards a blue economy. Such activities are advanced and developed by the World Bank Group, the Food and Agriculture Organization, the United Nations Environment Programme, and the Global Environment Facility. For instance, the World Bank has launched a major initiative named ProFish for promoting sustainable fishing to primarily assist the fishing communities in developing countries. The assistance is provided through improved governance and technical, financial, and market support. The second category proposes new and innovative funding mechanisms such as blue bonds. Now, the blue economy has two facets. Firstly, it provides opportunities for growth and development, and secondly, the protection of threatened and vulnerable spaces. In the context of the blue economy, the United Nations Development Goals highlight the need to balance the economic, social, and environmental dimensions in relation to the oceans. The United Nations has also declared 2021 to 2030 as the decade of ocean science for supporting efforts to reverse the cycle of decline in ocean health. The World Bank lays particular emphasis on balancing the triple bottom lines of sustainable development as a key component of the blue economy. Such triple win policies are aimed at integrating and finding synergies between social development, economic growth, and environmental sustainability. They are the future of development. So, a sustainable ocean economy brings together diverse stakeholders together to achieve the common goals of effective protection, sustainable production, and equitable prosperity. Sustainable production based on regenerative practices such as climate-ready, ecosystem-based fisheries management, along with fully protected areas, for example, can help restore ocean health. This results in a triple win for people, economy, and the nature, and a world where prosperity is greater and more equitably distributed than it is today. The considerable rise in green bond issuances in India is not only indicative of the rising awareness of sustainability issues, but also of positive behavioral change of investor interest towards sustainable investments. There is scope to capitalize on the growing corporate interest in sustainable ocean finance. With the development of the green bond market, it diversified from public sector issuers to more corporate issuances from financial and non-financial institutions. The presence of a policy framework will enable for-profit investments to fill the funding gap in public finance. For example, revenue from tourism and fisheries can be directed towards conservation activities to restore ocean health. In fact, it is often the developing countries that face the greatest consequences from global investments in unsustainable ocean economic activities, with impacts spanning fish populations, tourism, food security, and livelihoods. It is important to support improved policies, regulations, and financial levers for shifting from harmful practices towards sustainable activities. The physical nature of the ocean also has implications for financing sustainable ocean activities. It can be difficult to define and enforce access and property rights in the ocean because of its remoteness. Furthermore, public funding is also currently limited, and most estimates show that the full cost of establishing and operating marine protected areas in line with global goals would far outstrip available conservation funding. Other forms of ocean finance are therefore required to link ocean sectors with funding for conservation and sustainable use, which is why effective maritime governance requires the prioritization of the underwater domain awareness framework. The blue economy is one of the key stakeholders of the UDA framework. The UDA framework addresses the multi aspects of capacity and capability building and policy and technological intervention to attain a secure, safe, and sustainable growth model for the Indo Pacific region. Blue bonds can help raise funds to invest in science and technology to develop viable and sustainable ways of undersea exploitation and exploration. Additionally, currently the maritime domain awareness is presently limited to the surface, with majority of the maritime domain being underwater. It only superficially addresses and can be ineffective and detrimental in the long run. The UDA framework recognizes the economic potential in the region that can be harnessed by the nation. In the absence of a regulatory framework, the undersea resources are not being utilized in a sustainable manner. The UDA framework is focused on the underwater domain monitoring to address the four main stakeholders, namely national security, disaster management, environmental controllers, and the blue economy. The UDA will help uncover the vast maritime resources in India's exclusive economic zones to utilize them to their full extent. As mentioned, the blue economy is a core component of the UDA framework, and here is a link between the blue bonds and the UDA framework as shown by my flowchart. In order for a country to transition towards a blue economy, it requires capital. This capital can be raised through blue bonds. However, there are steps involved in blue bond issuances. Firstly, they must be aligned with ICMA principles with the blue bond framework to govern them. Securing a second party opinion ensures transparency and credibility as it verifies the proposed use of proceeds, project selection, and the evaluation process, along with oversight and reporting structure. After these steps, the bond is listed on an exchange and distributed to investors, providing capital for blue projects which needs to be repaid later. This blue use of proceeds can be then utilized towards projects such as sustainable fisheries, aquaculture, ports, and shipping, which in turn move the country closer towards developing its blue economy. In terms of India, it has a unique maritime position. The blue economy is a vast socio-economic opportunity for coastal nations like India to utilize ocean resources for societal benefit responsibly. India's draft blue economy policy is crucial towards unlocking the country's potential for economic growth and welfare. It recommends the government raise financing for blue growth with close coordination with global and other financial institutions to coordinate multilateral funding through blue bond markets. As mentioned, oceans are a major economic factor for India, supporting fisheries, aquaculture, blue trade, tourism, and livelihoods. India is one of the frontline nations in marine scientific research and is also actively engaged in exploring the resourceful ocean bed. The blue economy was highlighted as one of the 10 core dimensions of growth as laid down in the Government of India's vision of New India by 2030. The Indian Ocean also plays a vital role in the economy. Indian Ocean nations have the capability to build and underpin sustainable blue economic growth. The blue economy serves as a framework and policy for sustainable marine conservation as well as new marine based technologies. The centerpiece of India's push for the blue economy is the Sagarmala project, which was launched in 2015. It is a key to a comprehensive port led coastal development. With an estimated 80% of the world's trade carried by the seas, international shipping and ports provide crucial linkages in global supply chains and are essential for the ability of all countries to gain access to global markets. Guidelines for listing and issuing green bonds were first introduced by the Securities and Exchange Board of India in 2017, creating room for future growth for other thematic bonds. These guidelines could allow for other instruments such as blue bonds. Globally, blue bond issuances have crossed the $10 billion mark, but India has yet to enter the market. Given the increasing water-related concerns and the rising financing gap in India's water sector, it is imperative to explore the use of such innovative mechanisms to enhance private investment in the water sector. It is believed that by undertaking blue economy initiatives, countries would be able to achieve a high economic growth and maintain healthy balance between resource use and its renewability. However, it does come with its own set of limitations. As mentioned, there are currently no globally approved set of blue bond principles under ICMA standards to govern it. There are also high costs associated with issuing a bond, and as a result, most blue bonds need to be at least $50 million to $550 million in scale. A sizable portfolio of blue projects need to be identified to service their debt over time. Additionally, these projects are not self-sustainable. They can generate money only if charges are levied on a beneficiary, and given the remote location and vast nature of the oceans, it can be difficult to identify them. Often, it is government agencies that are identified as such beneficiaries, and hence there is a limit to the amount of money that can be invested in such projects. Hence, they require a revenue model which is less reliant on government aid and more on money generated by the project itself. Moving on to future direction. Blue bonds can support existing blue projects. Today's fisheries and aquaculture sector hosts a multi-billion-dollar industry that is a vital source of food and nutrition, employment, trade, economic well-being, and recreation. Unsustainable aquaculture practices have threatened wild fish stocks, which are being depleted as they're caught and used to feed farm-raised shrimp. These have contributed to the destruction of mangrove forests and other wetland ecosystems, which filter pollution and prevent erosion and promote biodiversity. Blue growth looks to further harness the potential of oceans, seas, and coasts to eliminate harmful practices and instead incentivize approaches which promote growth, improve conservation of shrimp aquaculture. While more sustainable shrimp production methods are available, they are not widespread, notably due to the lack of support from existing policies and concessional funding, which can be made available through blue bonds. Moving on, they can also support projects such as the Inland Waterway project. The Inland Water Transport Network comprises of over 14,500 kilometers of navigable waterways, and despite water transport presenting a cheaper alternative, it only holds a 7% share in coastal shipping. This revival plan requires public and private investment to fund development of ports, infrastructure, and shipping, as well as navigation to link connectivity. So blue bonds can provide financing for such projects and help countries such as India transition towards a blue economy. And with that, my presentation comes to an end. Thank you.
Thank you, Tanvi, for the comprehensive presentation. Maybe I'll go next now. Divya, if you can present my slide. Yeah, thank you so much. Hello, good evening, everyone. My name is Atul Kumar, and currently I'm doing my MBA from IIT Roorkee. And at MRC, as an intern, my topic for research was sediment management for the Brahmaputra River. Can you go to the next slide? Divya, next slide. Yeah. So these are the contents of my presentation. Next slide. Thank you. So Brahmaputra River, as we know, originates from the Yangtze Glacier in Tibetan Himalayas, and it traverses almost 2,900 kilometers to reach the sea, out of which 1,600 kilometers is traveled in China, followed by 900 kilometers in India, and then 400 kilometers in Bangladesh. It is one of the largest river for our country, and also has an average depth of 125 feet and has an average width of 9.5 kilometers. This large river system supports a life of around 190 million people across the three countries that it flows from. The rivers enter in India from Arunachal Pradesh and finally drains into the Bay of Bengal. The Tibetan plateau from where the river originates is actually 4 to 5 kilometers above the sea level. And when a river flows from such a great height, it gathers a lot of pace. As a result, it erodes a lot of loose soils and rocks that comes along its way, which eventually results into sedimentation. The fact that the Brahmaputra River accounts to 30% of the total water resources on national level and 40% of the total hydropower potential means that it is a very important river system for our country, and any problem related to it is a cause of national concern. So it becomes imperative that we have a very good understanding of underwater domain awareness regarding the river so that we can take right measures to treat the river and get the best out of it. Next slide. So the objective of the project was to understand the current policies that are there in place for the river, and also what more can be done in this regard to increase the effectiveness of the policy framework along with the enhanced underwater domain awareness for the Brahmaputra River. Next slide. The methodology thus adopted for this project was first to understand the existing sedimentation issues in the river and then to review the current policy frameworks and the gaps that are there in it. Also, to establish a global to Indian perspective, overview of policy framework that is there in place for Yellow River was done before discussing the policy changes or the scope for policy interventions in Brahmaputra River. These were majorly done with the review of comprehensive papers and literature available related to the topic. Next slide. Yeah. So the literature review for the sedimentation issues was done in three major parts. The first was for the sedimentation issues. Here, various papers from different authors and publication helped me understand that the existing sedimentation issues like the change in morphology of the Brahmaputra River, the braided channels of the river, as well as how all these are related to the sedimentation problem, and also how the factors like soil erosion and floods are actually interlinked with the sedimentation issues. Next slide. The second part of the literature review was concerning the current policy framework that is there in place for the Brahmaputra River and is responsible to take care of the river. Papers from Anthem Press and Observer Research Foundation helped me understand what is the role that government and the institutions plays in the whole scheme of things and what are the challenges that they face on regular basis. Also, it helped me understand the role of institutions like Brahmaputra Board that plays in the betterment of the river. Next slide, Divya.
Atul, we lost your voice. Are you there?
Divya, next slide. Yeah, thank you. The next review was related to the policies in place for the Yellow River. The reason why Yellow River was taken into consideration because it is important to understand the whole geographic and the dynamics of the Yellow River, as it also faced the same issue as the sedimentation, and China was successful in mitigating the issues that was caused by sedimentation. So this helped me understand in understanding how effective the soil and water conservation policy was in terms of mitigating the issues caused by sedimentation in China. And it also helped me establish a global to Indian perspective in the whole scheme of things. Next slide, Divya. Yeah. So this is the mind map which I have put together after doing all the research work done here. So at the center, we have the sediment management for the Brahmaputra River and the various branches. Yes, the various branches suggest the various factors related to the topic. The first is obviously the causes that eventually leads to the whole sedimentation problem. These causes comprises of anthropogenic activities, soil erosions, movement of the glaciers, as well as various climatic changes in terms of heavy rainfall that occurs. The issues that are caused because of these causes are segregated in two parts. The first issue is concerning the dam and the reservoirs. The second is regarding the riparian ecosystem issues. In dams and reservoirs, the issues that occurs are like the water holding capacity of the reservoirs and dams are reduced because of sedimentation. Also, it hampers the productivity of the dams and reservoirs. And in terms of the riparian ecosystem, the issues that generally originates because of sedimentation are that it causes the change in the course of the river, and it also in some way or the other contributes to the floods that happen on a regular basis. It also had an adverse effect on the aquatic life of the river. Then the stakeholders who are related to the sedimentation for the Brahmaputra River is the Inland Waterways Authority of India. The Brahmaputra Board is there along with the Assam and Arunachal Pradesh government, and the Central Water Commission along with the local people who are dependent directly on the river. The sediment strategies which are there in place are segregated in three fronts. Here, the first is the yield reduction, which actually talks about mitigating or limiting the sediment origin from the origin itself. And this is done with the help of embankments as well as afforestation and adopting various vegetation practices, which ensures that least amount of soil erosion happen, which will eventually lead to sedimentation. The second is sediment trap, which actually talks about digging traps in the riverbeds, which helps in catching the sediments in a much smaller area rather than it being circulated to a much larger area. The third is sediment removal, which is a very sought after techniques or method used to solve the sedimentation problem. And it comprises of dry excavation as well as dredging and sediment redistribution along with sediment siphoning. The policy gaps that are there in place is the overemphasis is at times given to one issue, which leads to the negligence of various other issues or aspects of the river. Then also the absence of integrated or holistic river-based management system, which actually leads to a lot of gap and time taken in resolving any issue that arises in terms of sedimentation for the river. The capacity or the capability building that the scope is there for the Brahmaputra River is that we can have a much more better and we can do the strengthening of the institutions so that it becomes much more capable and potent enough to take decisions to mitigate the issues that happen because of sedimentation. Then we can also have better hiring processes so that we have a very well skilled workforce available at our disposal to take care of the river, along with promotion of other water resource building, and also better infrastructure and system to handle the flood related issues in terms of forecasting as well as avoiding or mitigating the disaster that happens due to the floods. Next slide, Divya. The policy approach framework which I developed here is highlighted in this slide, and it is in two fronts. Like the first policy intervention can be done in domestic side, and then the second can be done in the international side. The domestic side actually interventions like we can have is the regular survey of the Brahmaputra River, which will help us in understanding what is the sediment type that is there in the river, and also forming of a dedicated body which can take care of the river in order to restrict or mitigate the sedimentation issues. And the hurdles I've also discussed, like in implementing the intervention for the domestic aspects, there are hurdles that can be there, like there could be a lack of skilled workforce which will be conducting the surveys. Also, having a fool to conduct the survey is one of the challenges here. Then taking approvals from various stakeholders involved in the river can become a cumbersome task because it can be a time-taking process in order to implement any of the suggestions or measures taken to manage the river. Then in terms of international side, the intervention that is proposed here from my end is we can have a mutually agreed memorandum of understanding as well as agreement to share the benefits between the countries who are directly involved with Brahmaputra rivers, mainly China, India, and Bangladesh. And also we can have a look at the UN's non-navigation law, which actually talks about sharing the benefits of a transboundary river, which between the nations that are concerned with it directly. The hurdles that we can face in implementing the interventions in international front is that that the lack of an international regulatory body which will take care for the implementation of these interventions is one problem or one hurdle that we can face here. then also reaching a mutual ground to discuss all or any of the policy changes proposed can become a hurdle in implementing these policy interventions on international level. Next slide. The domestic framework is something which might look like this in this slide. The topmost level is a dedicated body which takes care of the Brahmaputra River, and this body will be aptly and very much supported by international bodies as well as domestic body. The international support can come in the shape and form of World Bank's fund initiative that has happened in past, whereas the domestic support can be gained from various bodies like Inland Waterways Authority of India, Central Waterways Commission, and Assam as well as Arunachal Pradesh government. The dedicated body for the Brahmaputra River will be getting inputs from two fronts, and the first is the basin representative and second is the sub-basin representative. The representatives of the basin as well as sub-representative will be getting inputs from the departments like HR department, survey department, forecasting department, and the local authority. So this is how the workflow of the domestic framework will look like, where the inputs will be given from from department which works on ground level, and then it will be forwarded upwards towards the dedicated body which is there in place for Brahmaputra River. Next slide. For the international framework, the exact framework looks like this, where the topmost level comprises of Council of Ministers, which will be supported by the Technical Advisory Committee. The Technical Advisory Committee here will be responsible to provide inputs to the Secretariat as well. Secretariat here will be taking the inputs from the country officers and then will forward it to the Council of Ministers. The inputs that the Secretariat will gain is from the country officers, and the country officers will obviously be from the 4 countries that is directly or indirectly involved with the Brahmaputra River. Like the 3 of the countries here, China, India, and Bangladesh, are directly related to Brahmaputra River, whereas Bhutan also becomes a major player here because the sub-basin of Brahmaputra River is concerning the Bhutan as well. So all the country officers from their respective countries can give inputs from the input that they receive from the working groups, and the working groups can be in terms of hydromorphology, floods and climate change, as well as biodiversity, then economics and the governance working groups. So in this way, the whole system of international framework will look like, and it is supposed to work. Next slide. Then finally, the whole idea of sediment management in the Brahmaputra River is actually very much important and is very much in line with the revival of waterways transportation. As we know that waterways is an area or a segment which has been neglected field for a very long period of time, and the major stakeholders involved there the Inland Waterways Authorities of India as well as Central Water Commission, the World Bank, and the local riparian population. The India is blessed with navigable waterways of 14,500 kilometers, including river canals and backwater creeks. However, the 55 million tons of cargoes which are transported every year, out of which only 3 to 4% is done with the help or done via the waterways transportation, which is a very less number, and there is a certain and obvious scope of improvement in this regard. And the sediment management, if done properly, will surely act as a catalyst in the much awaited development in this segment. So it is also very much supported and has got a major boost from the recent budget that was proposed by our finance minister, where it is explicitly mentioned that in the coming 3 years, there is a plan to develop 100 cargo terminals under the PM Gati Shakti master plan. So all these things will eventually leads to a same direction of the development of the waterways transportation. So that was it from my side, and I will invite the next intern to present. Thank you.
Thank you, Atul, for your presentation. I'll be sharing my screen in a moment.
The presentation was very nice. Atul Kumar's presentation was very nice. Compliments.
Thank you, sir. Thank you for your compliment.
I hope my screen is visible. So a very good evening to one and all present here. My name is Barnik Goswami. I am a MBA student at Department of Management Studies, IIT Roorkee. And at MRC, my project mainly centered around policy suggestions for URN management. Now, we'll be talking about the background, the objective, the URN management measures, the suggestions for policymakers, and lastly about capacity and capability building. Now, starting with the introduction, URN chiefly refers to noise from three parts of a ship, namely the hull, propeller, and the machinery. Now, over the past few decades, URN levels have risen rapidly due to mostly anthropogenic causes, such as the tremendous increase in shipping and the percentage of global seaborne trade. A relationship exists between the change in underwater noise levels and shipping, which is shown here. And though URN is a growing cause of social and environmental concern, uh, not much steps has been taken to curb it, as in sharp contrast to other marine pollutants, URN is generally intangible. Now, coming to the impacts of URN, URN has impacts on both marine animals as well as socio-economic impact on humans. Now, for marine animals, it starts with acoustic degradation, which is where URN interferes with the perception of habitat of marine fishes and animals. Then URN can also lead to acoustic masking, which is the tampering of the long-range communication signals that marine mammals often use to communicate. And as these marine mammals often use sound to communicate and perceive their environment, high levels of ambient noise can also increase their environmental stress and consequently lead to changes in their behavior, growth rate, and reproduction, as it interferes with hunting and interspecies communication. Next, we come to the socio-economic impact on humans, and the first would be the impact on fishing, as URN affects the breeding rate and the growth of fishes. It impacts marine tourism. URN is also shown to disrupt sustainable development and can even lead to loss of livelihood. Now, coming to the gaps and limitations, I would be specifying them in the Indian context specifically. Now, though many studies have shown the negative impact of URN on marine ecosystems, there is still a lack of substantial knowledge quantifying the extent of damage that URN causes. Another hindrance to policy formation has been the uncertainties surrounding the effectiveness, efficiency pollutants. Noise has to be quantified at the source and with respect to the surroundings. Like a ship emitting the same level of noise would be much more threatening when passing through a rich biodiversity zone than when passing through an largely uninhabited expanse of the ocean. Also, capacity and capability building is a challenge in a country like India, where a large section of the workforce lacks formal technical education. Now I come to the objectives of my project. The objectives have been to identify the stakeholders and the policymakers for URN management in the Indian scenario and how can they come together for policy formation as well as enforcement. Also, I have analyzed existing policies and laws in place by the stakeholders and like how measures to curb other forms of pollution translate to URN management. And then lastly, it's about adapting the state-of-the-art global policies followed by the American subcontinent as well as the European Union with respect to managing of URN and figuring out ways to implement it for India. Some of these would be like utilizing monetary incentives, certifications for noise emission in limit, tax subsidies, etc. Now I come to the technological measures for URN management. Now, as mentioned previously, the sources of noise from commercial ships and vessels can be classified into propeller, machinery, and hull. And the primary way of reducing hull noise would be to come up with an effective design. And it has been shown by multiple research papers that with a meager 1% increase in the manufacturing cost of a vessel, a noise reduction of as much as 10 decibel is possible, which increases to 20 to 40 decibels of noise reduction with just an additional 10 to 15% building cost. Now, another significant source of noise from vessels, which accounts to almost 80 to 85% of the ship's total noise, would be propeller cavitation. So above the cavitation inception speed, the rotating propeller generates oscillations and it causes variations in water pressure large enough to cause bubbles of water vapor to form, which subsequently collapse and emit a substantial amount of noise. Now, cavitation can again be reduced by modifying the propeller and by exploring new technologies such as the contracted load tip propeller, high skew propeller, propeller boss cap fin, etc. Moving on to operational measures, ship speed restriction is currently the most effective operational measure shown to reduce URN levels. However, it comes with a trade-off that the slower vessels take a very longer time to transit, leading to a trade-off between the duration to which the noise is duration in which the noise is emitted as well and the intensity of noise exposure. So one study indicated that an optimal trade-off might be obtained between this duration and intensity at a speed of roughly around 8 knots. Also, poor maintenance can lead to marine fouling on the propeller, and this can henceforth increase cavitation as well. And this would also increase the surface roughness on the hull, which would increase drag, thus even leading to consumption of more fuel. And also regular maintenance of the propeller and hull may therefore achieve reduction in URN as well as lead to less fuel consumption. Now coming to activity reduction measures. Now, many of the European Union countries have adopted policies incentivizing the use of fewer larger vessels for shipping cargo. Like it has been shown that although large vessels tend to generate more noise, their greater carrying capacity often offsets their higher noise output and thus reduces the cumulative noise levels. Also, spatiotemporal restrictions can be put on shipping routes, specifically to avoid sensitive areas of the ocean during particular periods of the year, such as during the breeding season, or maybe avoiding the whale or marine mammal migratory routes, etc. Now, I have come up with a schematic diagram for URN management. On the leftmost side, the red boxes briefly relate to the URN emission right from the causes of URN leading up to cumulative URN levels. The next column shows the subsequent, the next two columns rather, show the subsequent measures that could be undertaken to reduce noise at that particular level. For example, suppose we start with causes of URN generation in the leftmost column, and this can be reduced by policy controls and subsequently technological and operational measures. And the rightmost column shows the examples. For example, in case of technological and operational measures, it could be quiet ship design guidelines and promotion of research to improve vessel design to reduce URN. Next, I have classified measures into measures for new vessels as well as measures for existing vessels. Now, in case of new vessels, substantial research must be undertaken to form a quiet ship design guideline, and this should be enforced at the design stage, either via economic incentives or with mandated standards. Now, enforcing mandatory standards based on the noise output of individual vessels does seem to be the most easy option here. And a different approach could also be taken where the noise requirements are scaled to vessel transport capacity and targets are undertaken to reduce the noise to capacity ratio of a vessel. Next, we come to measures for existing vessels. Now, an international standard does exist for measuring ship noise emissions, but it does not take into consideration the operating conditions of the vessel. But noise output from a vessel will vary with ship speed and even with other operational or environmental factors. And hence, measurements should be made under realistic conditions. When we translate that to the case of India, measurements should be taken along shipping routes rather than around ports. And these could be easily implemented in high density shipping routes in the Bay of Bengal as well as the Indian Ocean. Now, registries of vessel noise output could then be compiled at a national level, and that could be updated periodically so that the stakeholders do have a database of the noise emissions of ships. Now, this program can then subsequently offer some incentive to ship owners to have their vessels assessed periodically, and if their noise emission levels are in a particular limit. This would also ensure that the vessel operators have some incentive to undertake periodic maintenance. Next, I come to the capacity and capability building. For this, a central data pool of information can be developed, which would be a way for stakeholders to share know-how as well as their progress on the efforts they are undertaking to curb URN. Now, one of these primary efforts could be to undertake the formation of a state-of-the-art ship design guideline, which would again be shared with the shipbuilders, owners, operators, the shipyards, etc., through the aforesaid data pool of information. Then another step would be to undertake the education and training of operators, associated personnel, and everyone else involved with ship operation as well as in yards, both onshore as well as offshore. Also, substantial research must be undertaken to quantify the effects of URN and appeal to stakeholders the financial benefits of quieting the oceans. That would be all from my side. Thank you.
Thank you, Barnik, for that presentation. I'll be sharing my screen next. Please let me know if it's visible.
Yes.
Good evening, everybody. I am Sarthak Raj. I am a second year student at IIT Bombay pursuing my BTech in civil engineering. And today I am here to present my project, which focuses on the design and development of autonomous underwater vehicles for low frequency ambient noise validation. In the oceans, ambient noise is a complex combination of natural and anthropogenic noises caused by wind, precipitation, shipping, and exploratory activities. We classify ambient noise into frequency bands, and for our purposes, we'll be focusing on the low frequency band. There are basically natural and anthropogenic sources of noises, and commercial sonar technology is ineffective in tropical regions. So getting more complete noise maps is challenging. There have been mathematical models which are created and involve the training of neural networks using partial data to generate complete noise maps. AIS data has also been used to generate shipping noise maps in various tropical regions worldwide, but we require a custom solution for Indian Ocean region to validate such mathematical models. So boats and diver operated hydrophones are obviously limited by human capacities, which are overcome by remotely operated vehicles and autonomous underwater vehicles. AUVs provide an advantage over ROVs because they can be operated autonomously and remove the need and the risk of tethers. They can also venture to deeper regions with ease to provide a more comprehensive noise map. So what is an AUV? An AUV is an unmanned submersible vehicle that requires no real-time input or control from a human operator and therefore drives autonomously. They have many uses, and acoustic measurements is one of them. They can find shipwrecks, they can explore area, they can map the bathymetry, as well as localize noise sources by deploying hydrophones in clever arrangements. When it comes to AUV design, there are three main subsystems that we focus on, that are the mechanical, electrical, and software subsystem. I will be talking about these in greater detail. In the mechanical subsystem, our main design concerns are the buoyancy of the vehicle. It must be positively buoyant so that in case of failure, it can naturally rise to the surface. It must have 6 independent degrees of freedom for control over its navigation. It must be stable, and the drag calculations must be taken into account. As far as the propulsion system is concerned, the propulsion happens using thrusters and propellers. And using 6 independent thrusters, we can gain 6 independent degrees of freedom for motion. The drag and power consumption must be calculated so that the thrust that is provided by the thrusters can equal the drag that is experienced by the vehicle as a whole. As far as the shape is concerned, for our purposes, non-torpedo AUVs provide a greater control at the cost of maximum velocity. Since hydrophone sensing does not require movement at high constant velocities, this offers us greater freedom. It also provides a greater choice for hull design, therefore increasing the modularity of the system. The types of hulls that I've previously mentioned are the main hull, which can provide a waterproof vessel for the main electronic stack, including the onboard computer. Battery enclosures, which are attached so that they can be easily accessed for removal and replacement. IMU stands for inertial measurement unit, which uses the magnetic orientation of the Earth. It requires a special hull made out of non-metallic materials to prevent shielding. And camera hulls, which are designed in-house so that cameras can be provided access in the forward direction as well as below the submarine. The assembly of the vehicle happens on a main frame on which hulls are attached. Placement of some hulls should be done at particular positions like cameras in the front and at the bottom. Electronics that are housed in various hulls are connected through neutrally buoyant cables which are weaved through penetrators. The most important aspect of the mechanical design is the waterproofing of the vehicle. It is essential for the protection of electronics, as at high depths, even a small amount of leakage can cause catastrophic failure. The end caps that are placed on the vehicle must be waterproofed using the O-rings in accordance with the Parker handbook. Special attention must be given to penetrators because they can be likely points of failure. We will move on to the electrical subsystem. There are basically the main components of the electrical systems are the power source, the computer, the GPU, and the electronic stack. The following flowchart tries to provide a flow of control for the electrical subsystem. Basically, it's divided into multiple modules which perform their own specific purposes and are connected together by the CAN bus. The CAN bus allows intercommunication of said modules as well as communication to the software stack, that is the GPU and the SBC. Let us talk about the battery management system. A battery cannot directly be connected to an electronic stack because it may suffer failures which can be catastrophic for the system. A BMS is designed to allow the efficient discharge and management of the battery. It measures the state parameters like temperature, discharge rate, state of charge, and state of health. It also implements features like battery hot swap and cell balancing, which allow us to utilize the battery to its maximum capacity. Not all components will operate at the same voltage that the battery provides, so regulation must be done. This is done by the power distribution system. Common voltages like 12 volts, 5 volts, or 3.3 volts will be generated upon separate rails. The current requirements need to be taken into account. Additionally, digital switches like MOSFETs can be installed to provide a way to turn components on and off by using software to allow or cut off power. A GPIO pin on a microcontroller unit has no predefined usage as they can be modified during runtime. For us, they will be used to establish control from a higher layer, that is the software system, to the rest of the AUV. The SBC communicates with the GPIO using USB or controller area network. GPIOs are commonly implemented by using ICs or microcontroller units. Additionally, GPIO systems are also responsible for generating pulse width modulated signals for analog control over thrusters. Apart from all of this, certain emergency protections need to be provided up to all the boards. These are the overvoltage protection, the current surge protection, and the reverse polarity protection. The overvoltage and reverse polarity protection need additional circuitry to be implemented, but the current surge protection can be implemented directly via a fuse. Now we will talk about the software subsystem. The following flowchart tries to provide an overview of the software architecture. I will briefly describe it. Data is gathered via drivers from the various sensors like the IMU, the DVL, and pressure sensors for localization. The data from cameras are used for vision, and the data from hydrophones are used for acoustics. All of this data is provided to the control system as well as the navigation system. The control system is responsible to implement the algorithms that are provided by the navigation system by implementing PID loops to provide the necessary power to the thrusters. It sends its data through the CAN bus to the electronic stack, which then performs the necessary actions for the thrusters. The navigation system itself tries to provide a path between 2 points A and B, and it tries to calculate that path so that the AUV does not face any collision. The mission planner is basically the brain of the software architecture, and it allows for various features which we'll talk about later. So drivers basically input data from various sensors and publish it to robot operating system. So localization, as I've previously mentioned, is done using IMU, DVL, depth sensors, and altimeters for the estimation of position, velocity, acceleration, and the orientation of the vehicle. The control system basically takes into account a set point input that is given by higher layers and uses proportional, integral, and derivative control loops to output what torques and forces are required by the thrusters to bring the vehicle into a specific orientation. The control system allocates power by sending signals from the SPC through the canvas. Vision is implemented using cameras. This is parallel to localization and control for dynamic variables. The data from the cameras must be taken as input to implement computer vision algorithms to identify objects that the AUV encounters. Using ML techniques is advantageous in certain situations where the water is not relatively clear. This is the perfect case for turbid lakes and ocean water, as custom calibration need not be done for every single environment. However, training the CV algorithm itself can be very resource intensive. Another challenge that the cameras face is that at high depths, vision is not a very reliable source of information. So the main navigation system of the AUV rests with the hydrophones. Speaking of the navigation system, it it is utilized in the often complex and rough bathymetry of the oceans and can calculate efficient paths like circles, ellipses, and pathological curves as well. Now about the mission planner. It is the top layer of the software subsystem, which runs over the software stack and acts as the decision maker of the vehicle. It stores that the tasks that the AUV is designed to perform, whether there are any prerequisites to the task, how many times the task should be attempted, and whether the task was a success or a failure. This can allow us to implement some form of intelligence in our system. As in, if it fails too many times, it can simply skip that task and therefore avoiding the error that it is stuck on that specific task for long. Now we'll be talking a little bit more about the hydrophone module and the underwater noise. So when hydrophones pick up acoustic signals, they not only pick up the ambient noise, which is our useful signal, they will also pick up self noise that is generated by the hydrophones, as well as vehicle self noise generated by various components like the thrusters. Now the self noise parameters must be minimized and denoised to get any useful signal. And standards basically suggest that the weakest ambient noise signal must be at least 6 decibel greater than the cumulative self noise. Regarding hydrophones, there are two kinds of hydrophones which are mainly available. The first one is the acoustic scalar hydrophones, which basically estimate noise level using omnidirectional pressure sensing. These are only designed to measure a scalar quantity, that is pressure. Acoustic vector sensors, however, also measure directional particle velocity apart from noise levels to measure acoustic intensity, which is a vector quantity. Due to this ability, it has been proven to provide hardware advantages over scalar sensors, as in localization algorithms need a fewer number of vector sensors to implement. Talking about arrays of hydrophones for localization, swarm robotics, which basically involves multiple AUVs, each fitted with hydrophones, they are deployed. Swarm or leader follower algorithms are utilized for the localization of noise source, path planning, and navigation. This is ideal in the scenario that the AUV is small and relatively inexpensive to build. If our AUV design is large, towed hydrophone arrays might prove a better option. It's basically a cable with equidistant hydrophones that is stored by the AUV. Higher resolution images can be obtained by interpolating the hydrophone array data. So far, after my project, the progress that has to be made is the CADing and analysis of the vehicle, iterative designs to determine the structural integrity, CFD stability, and thermal dissipative capacity of the current design must be established. The PCB design, programming, and assembly of the electrical stack in accordance with the control flow provided should be executed. Then the implementation and maintenance of the software stack code base for various components like the mission planner, navigation system, control system, and the device drivers must be executed. And finally, and the implementation of a noise source localization algorithm using an array of hydrophones and the necessary changes in the electrical and mechanical subsystems must be taken forward. With this, I come to the end of my presentation. Thank you.
Thank you, Sarthak, for your informative presentation. Now I will begin my. the screen visible?
It's loading.
Yeah.
Yeah, it's visible.
Can anyone confirm?
Yes, it's visible now.
Good evening, everyone. Myself, Shlok Nimani, currently pursuing electrical engineering. Hereby, I am presenting my research done on the topic APY analysis for shrimps and seaweeds farming. I have outlined the following content in my upcoming slides. So we will be seeing the shrimps and the seaweeds, the aquaculture and the associated UDA framework, the production prospects of aquaculture in the Indian Ocean region, the APY or area production and field analysis, the environmental consequences of the expansion of the aquaculture in Indian Ocean region. First of all, let's talk about the shrimps and seaweeds. So both are biological marine organisms. Seaweeds are mainly categorized into phytoplanktons, while the shrimps into zooplanktons. And scientifically, there are numerous species of seaweeds and shrimps which vary in their internal constituency. And it also makes their biological study much more involved and in-depth because they have to be categorized into various families and classes based on their growth patterns, and that have to be considered separately. If we talk about the shrimps, the shrimps are mainly seen as a source of food. Various delicacies all over the globe are being prepared by taking the shrimp as a central item. Not only that, they also act as a energy source which are rich in proteins, omega-3 fatty acids, antioxidants, and vitamins and minerals. Coming on to seaweeds, so you might not find various use of seaweeds as a food, but they are seen as a food of the future because of their sustainable farming, and they are also used in the industry for the manufacturing of several value-added products like pharmaceuticals because of their medicinal properties. Some of the cosmetics, they are also seen for their use in the feed of the cattle, and the manure from these cattle can be used for as a fertilizer substitute, which we will be seeing. They can be used as a biofuel or a bioplastic and can be seen in the wastewater treatment industry. Coming on to the aquaculture and the UDA framework. So these are the stakeholders which we have identified that are related most to the aquaculture. So coming on to the first one, that's the science and the technology. If we talk about the science, so science can be employed in the farming for a better future of the farmers and for a better growth of the economy. So if we talk about the scientific research or the biological research, so biological research on a certain organism have the capability to deliver the knowledge about the growth rate, the growth pattern, the reaction of the organism to the environment, the survival rate of the organism. All this can be studied from the biological researches. On the other hand, the technology, the development of the sensors in the current era, the rapid pace of development of the sensors, they can help us by providing the real-time data. This real-time data can help farmers for the real-time assistance of their farms, and they can even take the precautionary alerts to take any appropriate measures for their farms. The blue economy. So it's not just the word economy. And why is that? It's because it promotes the goal of sustainable development. The economy should not be, the growth of the economy should not harm the oceanic resources. And its main target is to provide the livelihood to the people who are most dependent on these resources. And the third is the marine environment and the disaster management. So the two questions which we have to ask to ourselves are how aware are we of the environmental consequences? Everyone knows that the every action has a certain consequence associated with it. So if we are focusing more on expansion of aquaculture, so are we aware of any negative environmental consequence? Are there any unforeseen consequences which we are not aware of? And how prepared are we for any disastrous events? So the disastrous event here means natural calamities or any widespread disease in the organisms in the aquaculture industry only, so which we are trying to focus upon. The production prospects. So this topic actually covers the motivation of why we are focusing on the aquaculture of the shrimps and the seaweeds. So first thing is that India is blessed with the geographical strength favoring the aquaculture farming of both shrimps as well as seaweeds. The temperature, water, salinity, and all the available geographic location. So this all favors the growth and the growth of the shrimps as well as the seaweeds. So if we talk about the 3 points on the left hand side, this talk about our strength, and on the right hand side, this talk about what our current status are. So if we talk about the strength, so India have around 11 lakh hectares land under the brackish water area. The brackish water is a water which is more saline than the fresh water. About the salinity of brackish water is about 10% to 32%, which is ideal for the shrimp cultivation. Even it can be checked from our ABY tool that about 5 ppt to 15 ppt is optimal for the growth of the shrimps, and we have that in our geographic strength. And about 2.17 million square kilometer area under the economic exclusive zone extending from the coastal regions. So we have this much of geographic strength, but the area on the right hand side, we can see that the area under cultivation for shrimps is just about 1.1 lakh hectares. So that means only 10% of the total potential is being harnessed. So it shows the vast disparity between what we have in terms of geography and what we are harnessing. Second, in terms of technology, so we can say that India has a reasonably cheap data rate. So we all have a good connectivity at our homes, and even the data rates are not too high and can be employed. The technology using these connectivities can be employed. So this is the right time to even work on these technologies, to intervene this technology in the farming. And thus, but on the other hand, we can even see that the India sharing fresh seaweed is about only 0.01%. So the reason of this may be about the study on the Gujarat, where it is shown that some of the farmers are not willing to grow seaweed because they feel they lack assistance in growing the seaweeds. So even with data rates, even with all the knowledge available on the internet, there are various documents from the government available on the document about the seaweeds, the growth of seaweed. Still we are lacking somewhere. So the reason might be the dissemination of the information is not being available to the farmers. The third thing, which is the launch of the Pradhan Mantri Matsya Sampada Yojana. So it is targeted to double the income of the farmer. So it improves the livelihood of the farmer, but it also promotes the sustainable aquaculture industry. So yeah, it is the most important thing that every industry should be made as sustainable as possible for it to be making the profits in the long run. But even on the right hand side, we can say that the friendliness, the technological intervention, and the digital identities of the farmers in aquaculture have remained low. The core of our research, that is the APY, or the area production and yield analysis. So the thing is to anyhow start to or to pioneer in order to intervene the technology in the aquaculture. So we are trying to optimize the yields, to study the patterns all through one tool, and that tool should be available to the farmers. So this whole analysis is bifurcated into two parts, because if we try to analyze it into one, so the better is to bifurcate into two parts where one is related to the other. So if we talk about the trends and pattern, so let's analyze trends and pattern through a flow chart. So on the top part, we can see that this APY compute tool, it takes the data from the MPDA, that is the Marine Product Exports Development Authority. So it takes the data about the shrimp production data, species wise. We have the data of the last decade on the basis of certain species. So we are trying to do 5 analysis with this data. That is the parameter visuals. The second thing with the growth rate of production. So the growth rate is positive. It indicates that the farmers are willing to enhance their production. The growth rate is negative. It means that in future we can see the declining trend of the production. The coefficient of variation. It is important to understand how stable the production, the area, or the productivity is in the last decade. Because if the variations are too high, that means the industry in that region is not stable. So this is the another mathematical parameter which we are working upon. Third is the area production correlation and dependence. If the area and production are highly correlated or highly dependent, that means in near future, because area, we have already talked that we are using 10% area. So we have a area, we have certain amount of area which we can use to enhance production. But the area is not unlimited. The area is a limited thing, and to promote sustainability, the major use the area comes from that same area which we are trying to integrate into aquaculture. It comes from another use. So if we are trying to enhance area into aquaculture, the same area will be declining from the agriculture. So the main aim is to make production more and more dependent on the productivity or the yield, so that even with the same amount of area, we can enhance our whole nation production. And the last thing is the overall change in the area in the last decade, because we are also trying to see that since we are only using 10%, So we should try to enhance at least up to 20 or 30%. So we have to see that in the last decade, how much the area under the cultivation changed. So that brings to the first part of the APY analysis. Coming back to the our first previous slide, the second thing is the yield parameter relationship. So this is a pure mathematical relations which we are trying to establish, and it involves how to relate yield with the parameters. So these parameters are the environmental parameters. And if we try to maximize the yield, in that case, with the same amount of area, our production can be maximized. And with low losses, the low waste in the industry, our whole industry can be made sustainable. So here, from the various researches, the biological researches, we are trying to categorize which factors affect the shrimps as well as seaweeds growth, trying to find some common parameters that can be integrated into one, and some different parameters which are not common to both, and trying to build the mathematical models, which is the second part of our APY analysis. So, like, let's try to understand what's the main benefit of our contribution. So, let's say on the top left, you can see that there are a lot of data. So that data cannot be understood directly. And even if one try to like calculate the parameters, so he have to first tabulate this all into an Excel sheet and make graphs and to tabulate using certain formula. But what if this all data can be fed to a tool that is managed by just like not too many are required, like just 2 to 3 persons which are there to manage this tool. So all these visuals, like we can see the visual of production, the varying production over the last decade from 2010 to 2021. And the production in Tamil Nadu, it increased by about 164%. That's the growth rate. The growth rate per year is about 164%. Similarly, the area under the cultivation in Tamil Nadu also increased, and the productivity can be seen as something sort of a constant. But yeah, the overall production in Tamil Nadu for the L1MA species have increased. So one can now see that it is too difficult to just see these numbers that are given on the web page. But if we have a tool that can give all sort of visualizations and all sort of calculations at one place, it will be too easy for farmers or the stakeholder to make certain steps that can be taken. If we see the obtained results about all the growth rate, about the tiger shrimp and the white leg shrimp or the L1MA shrimp, so we can see that the tiger shrimp showed the declining trend. So we can see that about Tamil Nadu. So the growth rate is highly negative. That means, and the similarly in the contrast, we can see that for the L1MA species, the growth rate is highest positive. So for Tamil Nadu, the tiger shrimp, the growth rate is highest negative, and for the L1MA, it is highest positive. So it indicates to us that the farmers of Tamil Nadu are either shifting to the L1MA because of higher returns or any other sociological reason or any geographical reason, that they are trying to figure out how the L1MA is more profitable to them. That's why the tiger shrimp showed the declining trend over all the regions, and in all the regions, the L1MA species have shown the positive trend. So let's try to concise all this into one. So we have certain conclusions that the growth rate parameter of the tiger shrimp has declined, while for the L1MA it has increased, and the wild shrimp, that is the scampi. So it was once, we can say that in the last decade, in the beginning of last decade, it was the major producer in the total exports basket of the India. But now the industry of scampi is it's just minimal in comparison to the Vaname and the tiger shrimp. Apart from that, the variations in these parameters are high over certain regions. So that may be due to the migrations in those regions, the switching of farmers to the other employment options. But this we cannot directly figure out because this data just tell us about there are some problems, but they don't give us the result that why these highly unstable variations are there in these regions. And the third thing is the dependence of production on the area. If production is highly dependent on the area, so that means that industry may not be sustainable in long run because the area is finite and the use of area should be in the sustainable manner. So the thing that drives us to the part of the yield parameter is to maximize the production with the maximizing the or optimizing the yields. So This brings us to the second part of the APY analysis, that is the yield parameter relationship. And if one can ask that, does the yield depends on environmental factors? So yes, we can see from various researches done on these both organisms, that is the shrimps as well as seaweed, that the biological factors of these organisms are affected by the surrounding factors. So these are the factors, the environmental factors affecting the growth pattern of the shrimp. These are the water quality of the pond, the temperature, the stocking density, that is the number of shrimps grown per square meter, the soil quality, the feed conversion ratio. The feed conversion ratio is actually the biomass of the shrimp or the biomass fed to the shrimp. The feed quality, how quality of the feed is good or bad, and the water clarity in which the shrimp is grown. Similarly, for seaweeds, we try to identify these parameters. Some of them are same, some of them show the contrast that are more important for the seaweeds. So the main focus will be on the sunlight intensity, the duration of the sunlight the seaweeds get, because their metabolism also depends on the photosynthesis and the light conditions. The skill assistance, as I have already explained, that some researchers showed that in Gujarat, the farmers are not willing to do the seaweed farming because they feel they don't have the required knowledge. And these researches, which we have make use of to formulate our APY tool and mathematical relations. So let's have a look on Weiban et al. So they give about temperature and shocking density, but they did not give any mathematical model. So we are pioneering in making the formulations that can be used for the development of a whole framework. And they told that the optimal yield should be in 23 to 30 degrees. And our tool suggested that the maximum growth rate lies at about 29.1 degrees centigrade. So that shows that our tool can be used as a mathematical model to even show how good or how bad our parameters are. And that can even help farmers to optimize their farms. And similarly, the paper by Nawabi on salinity on the growth of shrimps, that shows that the salinity is important, but higher salinities. This APY tool showed that the salinity decreases quadratically with the increasing water salinity. So if the salinity is too high, the growth will be decremented as a square of the variation of salinity. And similarly goes for the seaweeds also, about the pH, water pH, and the temperature and the salinity. The same relations and the same observations, and the tool formulations is different because the species have to be taken into account. And this is the our whole work, that how we are trying to establish the mathematical models. And the growth rate of the shrimp, the survival rate. The survival rate is important because only the survived shrimps can be sold into the market. And the growth rate with the varying pH showed that the basic pH is important for the growth of the shrimps. And these are the opportunities and limitations. The opportunities are the blue economy, as I've already explained, and the self-reliance. The farmers, if they have a certain tool in hand, so they are self-reliant. They can check their own farm. They can check their own parameters. The nation can harness the geographical strength. The work is now not only on the paper, because this work also employs the digital tool, the development of the tool, and the advanced researches like the application of machine learning or AI can now be built upon this whole work. And finally, the farmers which have the possibilities of higher yield can get higher investment too. So overall, their livelihoods improve, which is the main aim. And the main limitation in this whole research was the non-availability of structured data, because the data is available somewhere, and that is not structured. Because for any research, it is important, because the all the various researches today now employ the neural nets to formulate the models, but we don't have that to our disposal. So we have to try to use the curve fits, and using some only small amount of data. So there might be some error which will be removed if some effort would be made to conduct the on-site research that can get us some amount of data. And the thing to make this project a practical success would be to make farmers the friendly to the technology. And if we talk about the environmental consequences, because we have to comply with the blue economy guidelines. And if we talk about the shrimp aquaculture, so I would like to tell that, are we ignoring the long-term effects for the short-term benefits? Because the expansion of shrimp aquaculture in all the regions where the shrimp aquaculture has been expanded to a certain limit, it showed the prominent negative impacts on the associated region, like the biodiversity loss, the mangroves and the marshes, the freshwater crisis because of the salt intrusion into the soil, the discharge of the pond effluents. The pond effluents are acidic. The shrimp pond effluents are acidic, which are discharged into the freshwater resources without any treatment. The loss of land, because I have already explained, the land should be come from any other agricultural land or any other land, which can lead to the weakening of social relations, because the farmers which do the agriculture on their land may have the disputes with the farmers willing to do aquaculture. And finally, the water and the land use in aquaculture can show us the negative impacts, maybe even after a decade. Finally, does the same apply for the seaweed? So the answer is clearly no. As of now, there are no foreseen negative consequences, and even we can term seaweed as a pinnacle of sustainability. They act as a carbon absorbers because they use photosynthesis, so they absorb the carbon. They accumulate heavy metals from the water. They can be used in the cattle feed as they are nutrient rich. They trap essential amino acids from the water. They, from the process of photosynthesis, act as an oxygen generator, and the list is long because they can even be used as a biofuel. They can be used for the manufacturing of the bioplastics. They also absorb the nitrates and phosphate to support their own NP kinetics, to support their own life. They absorb nitrates and phosphate, and it is beneficial to us because it maintains the optimal level of nutrient. They can be act as a fertilizer substitute. And finally, some researchers show that they also act as an ecosystem guards because, similar to other vegetations, they also dampens the ocean waves. So these ocean waves which are hitting the coastal region, they can be dampened by this seaweed. And finally, the thing why we are focusing on these two is that the shrimps, on one hand, are showing negative environmental impact, and such industry, the development of such industry cannot survive in long run, because we have to also comply with the sustainable development of any industry, while the seaweed show the pinnacle of sustainability. So what we can do, just we can see the possibility of integrating both the things, but the polyculture possibility have been shown in the paper, but there is a long path from the paper to the practical. So that we have to build so that the farmers can make use of that. With that, thank you for listening to my presentation. And
Thank you, all of you. I think it was a good presentation, and I would like to put on record that it's a truly multidisciplinary and multifunctional projects that we have been progressing at MRC. So I would request Rajan sir to firstly, I would thank Rajan sir for supporting this internship program in terms of supporting the stipend for the interns. And Rajan sir, your comments, please.
Well, I'd like to compliment the MRC for suggesting these, selecting these subjects which are of current issues and current problems relating to the blue economy, especially, which the interns have done a great job, wonderful presentation, and I'd like to compliment them all for their research and the hard work that they have put in. I've enjoyed all presentations immensely, and I thank them for their presentation, and also you, Arnav, for organizing this and for encouraging the interns in their research. Thank you.
Thank you so much, Rajan sir, for your encouraging words. General Patil sir, would request you to kindly give your comments, please. General Patil sir, you may have to unmute yourself, sir. I think. Yes, sir. Patil sir, kindly give your comments, sir.
Let's listen to Mr. Rajan. I've heard all the 7 speakers. I'll give you my views on that later. I'll switch off now because I've got another meeting at 6 to 7. Okay. Very good. They're all professionals. It was an education to listen to all the 7 of them, including the last show. I would like to listen to Mr. Rajan.
Thank you so much, sir. Arun Sehgal, sir, your comments, please.
Good evening. Thank you so much. I really enjoyed the presentation. Very professionally done. And I have little else to add to what has been said earlier as comments. I learned a lot myself, and I am sure that we will take this forward in a good way under your guidance. Thank you. That's all I have to add.
Thank you so much, sir, for your encouraging words. Last word to Ashwin Shroff, sir. Let me warn the young interns that Shroff, sir, and his group is doing a lot of work on seaweeds. Ashwin Shroff, sir, please, your turn.
Right. Well, first of all, namaskar to everybody. And thank you, Dr. Das, for organizing a wonderful presentation, wonderful, I would say, plethora of presentations on connected subjects, but also at the same time, in depth for all of them. So, except for the first one, which I had some difficulty in connecting, the other presentations I heard. So, I think I was there for Atul Kumar's presentation on Brahmaputra. Then Sarthak Goswami. If I make any mistakes in the names, kindly pardon me and apologize. On the underwater vehicles, and then Shlok's presentation on shrimp and seaweeds. As Dr. Das, he said, I'm warning all of you. I don't know why he said warning, but anyway, we are enjoying working with seaweeds. And in fact, you'll be happy to know that I was at IIT Bombay today to meet some people on the subject of seaweeds. I didn't know, Shlok, that you are connected there. So I would like to invite those who are connected with seaweeds to contact us through Dr. Das, and we'll be happy to see how to associate you with the work that we are doing. Currently, our work is in the Kutch region, Kutch and Gujarat, but we see the whole country as really open to the aquaculture and especially seaweeds. We have 7,500 kilometers of coastline, and all the benefits that we see, but mainly our focus is on the climate change reversal. Not only just managing, but reversing it actually by taking out the CO2 from the atmosphere. So we are enjoying doing the work. It's a big subject, vast subject, and we cannot do it alone. We will need young minds and young energetic people like you to help us. And I would like to really, through Dr. Das, contact some of you who are interested. Those who are Mumbai based, it will be easier to contact. I am a Mumbai based person, but even others, we can, these days, there's no difficulty in contacting, but we'll be very happy to associate. But on the larger subject, what Dr. Das has been promoting is understand the sea. Go below the surface and understand the sea and all its dimensions. Most of them are good, most of them have been ignored. Some are bad, which we need to rectify. But by and large, it's an ocean of opportunities, and we need to really take care of that. And I think it will be really very, very nice to look forward to associating with some of you, and also, of course, with MRC, and all the activities that they are doing is really wonderful. So thank you very much. It was very, very educative, very, very professionally presented. So I would like to compliment all of you for the wonderful presentations. Learned a lot of new words, new concepts.
Thank you so much, sir. It's our team led by Sridhar. Divya is there, Ananya is here, Nishtha is here, and Arohi is somehow not able to join today. But we have some more interns who could not present today, partly COVID and partly their engagement in their institutes, because now it's again going through a transition phase where online and offline is just getting mixed up. So we will look forward to your support, sir, and the kind words will definitely encourage us to work harder. But I must definitely admit, these are young students from very good institutes who have come forward and taken up this particular area. Firstly, I would like to thank them also for choosing MRC, because I think the underwater domain awareness framework is extremely important. And these are the people who are going to be our ambassadors and our messengers to the rest of the world. And I'm very confident they are going to be occupying very high chairs at some point, and they having this at the back of the mind will, I think, do a lot to this initiative. So, I mean, we are happy to share that some of our previous interns have also done very well in their next level. So, and these people are definitely going to do well, I'm sure. So thank you, interns, for your good presentation and your good work, and all the senior panelists who have taken their time off. Thank you, sir, for being there. Yes, sir. Please go ahead, sir.
Can I take 2 minutes?
Yes, sir. Please, sir.
Yeah. Sorry, because I told you I had to attend another one, but before that, having heard Mr. Ashwini as well as Mr. Arun Saigal and the 7 speakers, Sridhar, Tanvi, Atul, Sarthak, and Shlok, Mr. Rajan, it has been an education and eye-opener. They have plenty of ideas, and what is required is we have to sit down and take those things out, convert into an action plan, because some of them connected with Brahmaputra River must reach Himanta, the CM of the Assam government, as well as the people who are supposed to take active part in that. And similarly, the others, main thing is whatever we have heard today, this has to be taken forward and not just recorded and kept. I have got few points which I sent you in WhatsApp instead of taking time on this. It was an excellent thing. I wish in future, it is only my suggestion, have not more than 6 to 7 for presentation, but others to listen to, because we can't ask such excellent professionals to finish their presentation in 3 to 5 minutes. It is not being fair to them. We'll give them 7 to 10 minutes and have a presentation team of not more than 7. It is my suggestion. Other things I'll follow up in the WhatsApp. Thank you, Ashwini sir. Thank you, Arun sir, and thank you, Aruna, and all the professionals who spoke today. God bless you all.
Thank you so much, sir. Thank you very much. Thank you, everybody. I think we'll close the session for today, and we look forward to your feedback, sir, even through a mail or a WhatsApp message. And thank you, interns, for a very good presentation, and you make the event a success. Thank you very much. Thank you, sir.
Oh, no, thank you all.
Thank you, Aaron. Thank you, sir.
Thank you, sir. Thank you, everyone.
Thank you, sir. Thank you, everyone.